Alright, so now that we've seen how to use the sum and difference identities to actually find values, we'll practice proving some of the identities. It's the same as what we did earlier in this unit. The only difference is now we know more specifically what formula we're going to be using, where our strategies are still the same. We'll always begin with the more complicated side. So number one, the left side is more complicated. Number two, either one would work. And then strategy two, these other ones don't necessarily apply as much. We don't want to change everything to sines and cosines. Basically what we want to do is use these sum and difference formulas. That's going to be our main strategy here. Alright, so on the first one we have a minus, that means difference. So we're going to be using this one right here. And we'll start with the left side. The left side is more complicated. So this is like our A value, that's theta is like our B. So it says when we have a minus, we're going to be using all the ones that are on the bottom right here. So sine of A, cosine of B. So since our A is 3 pi over 2, we'll make it sine of 3 pi over 2, cosine of theta, minus, and we're following this pattern right here, cosine of A. So in this case, that would be cosine 3 pi over 2 times sine of theta. We are trying to prove that that equals negative cosine. So 3 pi over 2 in terms of degrees, that's 270 degrees. You could change it by multiplying it by 180 over pi. If you do 3 pi over 2 times 180 over pi, the pi's will cancel. 2 goes into itself once, it goes into that 90 times, and 3 times 90 is where 270 comes from. So I'm just going to change these into 270s. Okay, now the question is, what's the sine and cosine of 270? Well, 270 is right down here. Cosine is the x-coordinate. The x-coordinate right there is 0. So this whole thing becomes 0 times sine of theta, and that whole thing just equals 0. So we actually don't even need to pay attention to that. The sine of 270 is equal to negative 1, because y equals negative 1 down there. So this whole thing becomes negative 1 times the cosine of theta, and another name for negative 1 times the cosine of theta is that right there. So we prove that the left-hand side equals RHS, means the right-hand side. Alright, so that was using a sum and difference of sine. Let's try one now with tangent. That's number 2, and I encourage you to, as always, to pause and see if you can simplify this. So I'm just going to move this formula over here so we have it in our line of vision. So we're going to be using the tangent formula, and this is a difference, because a minus means difference. So our A value is theta, our B value is 45, and then the minus right here means this is going to be minus, but then notice that plus is on the bottom. Just like minus is on the bottom in that first parentheses, when we're using minus for tangent, our denominator on the other side has to be plus. So let's simplify this out. So it's telling us this. It's telling us that the tangent of A minus the tangent of B is going to go on top. So tan theta minus tan 45. And actually we'll kind of color code this so we can see. So let's call 45 will be B. So this is tan 45, because this is B right here, and A is this value. Okay, then on the bottom we have 1, and then it's going to be plus. And again, why is it plus? Because minus is on the plus or minus. You could actually split this into tan A plus B, and then they give you some long formula, and then tan A minus B. And the plus represents whatever number's on top right there. It's getting blocked out, but whatever number's on top right there is what we're supposed to use. We're using the minus. We're using the number on the bottom, so we want to use this thing right here, which is plus. Okay, and then it tells us tan A times tan B. So again, tan A is tan theta times tan B. Tan B is tan 45. Okay, what is tangent of 45? In that table that you hopefully have memorized, tangent of 45 equals 1. So this thing equals 1, this thing equals 1. So another way of saying this is tan theta minus 1, that's what this top is, over 1 plus tan theta times 1, but tan theta times 1 is just tan theta. So we have that, and that's exactly what we set out to prove. This equals the right-hand side. So that's how we can use the sum and difference identities to prove trig identities.